I'm Shel Genneman. Carol Ann Clayson and I lead Butterfly, a satellite mission to reveal the ocean's impact on our weather and climate. This mission is being proposed to NASA's Earth Venture Mission 3 competition by the Farallon Institute. We have a diverse team of expert scientists and engineers and collaborators from all of our partners listed below, and several operational weather agencies around the world. Think about being near the ocean, near a lake or a pool, especially early in the morning, and watching the mist come off of the surface. That's what Butterfly is about. How the ocean supplies heat and moisture to the atmosphere. The ocean covers 70% of the Earth's surface, and we don't measure evaporation from space. The single largest component of the Earth's water cycle is evaporation. 86% of it occurs over the ocean, and we don't measure it. Current climate models disagree on the global means of heat and moisture by 100% and 20%, respectively. No agency has designed a mission or has ever designed a mission to measure the exchange of heat and moisture at the ocean surface, again, which covers 70% of the globe. So, how did we get in this situation? How it started? A decade ago, if you asked weather modelers, they just wanted a 100-kilometer daily sea surface temperature as a bottom boundary condition for their models. And it was because of this top picture. When you look at the ocean, okay, it seems like the atmosphere is forcing the ocean. Done. End of story. So how has that worked out? How is it going? Now we know that it's at the small scales where the ocean forces the atmosphere. And one of the most promising ways to extend the accuracy of our weather forecast past 10 days into accurate seasonal forecasts is by coupling it with the ocean. But we have no observational data to tune the weather and climate models. We know that fronts and eddies fill the global ocean and affect the air-sea turbulent heat fluxes at scales that we aren't able to resolve. And again, these are the exact scales that model study after model study shows a shift from linear to nonlinear dynamics and a fundamentally different balance in forcings. Simply put, there is a completely different view at 25 kilometers. Models show us that storms in the Eastern Pacific respond to 25-kilometer fluxes and their gradients differently. This deeper vertical circulation changes regional weather patterns, affecting weather across the entire United States, as well as Europe. Understanding this better has huge implications for subseasonal to seasonal forecasting and weather preparation. This saves lives. Butterfly is the first satellite mission to simultaneously measure ocean temperature and near-surface winds, air temperature, and humidity to estimate the turbulent air-sea heat fluxes. Launch date is 2026. With a swath width of 640 kilometers, we anticipate 91% global coverage in 2 days. Our footprint size is 20 kilometers, allowing the resolution of small-scale ocean features using a passive microwave instrument, measuring from 7 to 175 gigahertz. These channels are specifically designed to be sensitive to the near-surface data that we need. Butterfly advances 3 of the 6 key NASA Science Mission Directorate Science and Application questions for the next decade. It also advances many Decadal Survey most important and very important questions. Launching Butterfly in 2026 will enable better integration of air-sea coupling and weather and climate models, which are moving to higher resolutions, and that's anticipated in the next decade. It will amplify the UN Oceans Decade of the Oceans investment in ocean science and address Decadal Survey science priorities. The science community needs and is ready for this data. Butterfly will advance NASA's leadership in the global science community by providing unique space-based data not provided by any other agency to advance Earth system science. Thank you.